Okay, so we've moved on to our next tutorial. Let's make this a little less untidy. Now we're going to work with NeHe tutorial number 6. People tell me that these tutorials are obsolete, but I think they're a good way to learn more about how to program Squeak and how to interact with Squeak with an external library like OpenGL. And they teach you some basics of OpenGL, even if they are deprecated. Little quote marks in the air. So, let's look at our new little tutorial, and I'll inspect it at the same time that I open it. And notice it opens this little thing over here. This happens to be the default image. If you open a morph image, you will get this little thing. So let's actually inspect now our NeHe tutorial number 6 and browse the hierarchy. You'll notice it's got a few new methods defined. It's subclassed off of OGL morph tutorial. And the core of the methods right now that we will look at is load default image. Default image, the first thing it does is it creates a form. A form is a drawing area. It could be on screen, it can be off screen. It's basically a series of bytes that values can be put into. And if we inspect a new image morph without actually displaying it on the screen, by selecting it and going Command I, we will see that it has something called an image or a form, and that form has bits, a bitmap of length 1600. We can even inspect that and see it's got all sorts of numbers in it. Basically, it's a drawing area. Its width is 80 pixels high, 40 pixels, 80 pixels wide, 40 pixels high. Its depth is only 16 bits. That is to say, it can only handle 65,000 colors. And the offset isn't appropriate at this moment. Well, we're actually dealing with a 32-bit screen. So notice that when we create this new image, we recreated the form as a form of depth 32 and just grab that form. And then we grab the width and the height of that form, which is the width and the height of the image, and then we create a new thing called texture int names, which is a word array. This is going to be used by OpenGL. In our next line of code, we send it the number of images we want with the reference to our array, and it's going to return an array of numbers, probably starting with 1, which can be used as references to image. In other words, OpenGL now has an index of blank images that we can work with. Now we're going to work with the first image. We're going to say it's going to be a 2D image. Hello, cat. We're going to work with the first reference, which is probably 1. It's in the array at 1. We're going to say an OGL texture format, which incidentally I happen to know is an RGBA format, useful for Macintoshes in this case. If you were on a Windows or Linux machine, you might get a different value. And we're going to send OGL the enable message GL texture 2D, which means you're going to be able to work with these textures. We're going to send some definitions or some parameters to go along with our textures. And you'd have to look them up to see what's going on with them exactly. This one, I believe, will auto-generate mipmaps, which is basically different resolutions of the same image appropriate if you're at different distances from the camera. And now we get to the meat of the thing. We're going to say OGL text image 2D. Make sure we know it's a 2G texture. And we're going to send it a series of numbers which are defined in the OpenGL manuals. And the most important ones are the width and height, which will tell OpenGL what the width and height are, and the form bits, which is basically that memory area for drawing, which has our little drawing we got from the system, the default image. So we've actually created this image, and now whenever we refer to our texture 1, we will get this image. So let's go to the next interesting thing. Let's move this aside slightly. Notice I have a method called load image from user. Let's evaluate that, and we get a little cursor with a little corner which allows us to mouse down and drag and select a rectangle. And when we do that, it copies that rectangle. See, we've done an image morph in this method load image from user using the method grab image from screen, which does the whole thing of grabbing a rectangle. Make sure it's 32 bits. That may or may not have been necessary. I haven't checked. And then that's probably inappropriate named, but it means form from user width, form from user height. We now have 2 references. We're going to bind it with a second reference, so OpenGL now knows about this little image over here. And then we're going to go through the whole process again of creating a texture with the parameters we need, including the form bits that refer to the drawing that we have created from the screen. And we've already done this, so now whenever we do this method again, it's going to overwrite our second texture index that we created with image bound equals 2 and create a new image to go in the same place on the screen. So let's try this. Let's make a larger image. Notice I'm keeping track of these variables, the width and the height, so our texture is going to be drawn properly scaled. And in fact, if we go down to here and work with our vectors, notice I'm using the same methods as before, second translation vector, which positioned our little objects, 3D objects on the screen. I'm using that same method call to position our 2D textures on the screen. So let's bring that forward. And you can see it's nice and clear, which leads me to think that indeed it is using different resolutions of the same image that it auto-created for us. So if we go back slightly, we will start to see more of that image. Back more, we will see more of that image. Notice we get the entire rectangle that I selected. And notice that at farther distances away, it doesn't seem to be nearly as... Well, no, I'm wrong perhaps. It does seem to still keep a nice resolution. So disregard whatever I said about bitmaps. That might not apply. It may all be one resolution. But anyway, you get the idea. I could create a third method that would basically use this method. I could go through the process of loading an image off of disk. I could create a fourth method, which would grab an image from the internet. The only thing that would change would be this line of code. and perhaps this to specify a new width and height for the source. And so basically we have this entire routine which could be used to load any kind of image from anywhere, as long as Squeak has the image translation handlers, which it does for bitmaps and PNG, and I believe it can load in a few other file types. And of course people are always adding file types as they need them. So that's image handling in OpenGL using Squeak. Let's grab something new just to be silly. Load image from user. We're just going to grab that little bit. And there it is. See? And that could be actually put on a rotating cube or whatever.